We're Team 3, TheShard. Last week, we talked about constructional method. Especially, we talked about 2 points, crane and jump lift. At the crane, focusing points are core crane with slip-on method and recovery crane which helps to dismantle the tower crane. And engineers use jump lift to solve the vertical logistic problem caused by a high height of skyscraper. The construction of the shard was completed, but the maintenance of the building is also important, which related to building sustainability. Heat control is a significant part of the shard's sustainability due to its design and thermal condition of the London. So this week, we will talk about heat control system of the shard and focus on how they made it efficiently. Before looking at the shard building, we will explain about London's thermal condition. By looking at the annual sunshine and thermography of United Kingdom, London has high sunshine hours and temperature compared to average of United Kingdom. As London is the capital of United Kingdom, heat island effects is remarkable due to its high density of the city. Now, let's return to the shard building. Fundamental to Piano's vision of the building was the idea of lightness and transparency. Because of this vision, 11,000 glass panels, which take 56,000 square meters of outer wall, was used to the shard construction. These glass panels threaten the building's heat efficiency due to greenhouse effect and low thermal capacity. Plus, there is a factor that makes the greenhouse effect worse. To reinforce the transparency of the building, extra white glass which contains low iron was used instead of regular glass. Low iron glass provides better transparency but provides more energy transmission too. Due to this property of low iron glass, the greenhouse effect getting worse compared to using normal glass. Last, the skyscraper, like the shard, has a difficulty to balance temperature of the whole building. As the skyscraper has extreme height difference between the ground floor and the top, the temperature difference widens. These factors that threaten the building's efficiency, the shard building required high-quality thermal solution. Engineers provided various solutions for building efficiency, and we'll talk about in passive and active solution this week. First, let's talk about passive solution for heat control of the building. There are 3 points related to solar radiation reduction. First, single glaze fixed outer skin. To reduce solar radiation, outer glass panel is coated by epoxy bright white to increase sunlight reflection to 36%, compared to normal glass at 13% reflection. Next, double glass unit used to inner glass panel. Compared to single pane, double glass unit has more heat reduction due to cavity between glass panes. Cavity is filled with air or gas, which has a higher thermal resistance compared to glass. For the increased solar reflection, low E coating was used to double glass unit. Low E, low emission, means the insulation of infrared, which is main factor of radiation heat. The low E coated glass has less reflection of visible light compared to solar heat. Therefore, there is no significant problem with transparency while reducing radiation energy. Third, the roller blind at the inner space of the glass panel. The roller blind is made of glass fiber, which cut off 95% of solar radiation. There is a reason we classify the blind to passive solution, not active solution. The roller blind works automatically due to the sensor which responds to the sunlight. At the cavity between outer pane, which has a slit, bottom and top, and inner unit, the convection occurs, which helps to emit the heat of building. Passive solution reduces the solar radiation, so the building efficiency is increased, but it is not a fundamental heat control solution for the thermal comfort. To constructing efficient building, TheShard needed an efficient active solution for heat control. So, let's talk about active solution for heat control of TheShard. To know about TheShard's heat control, we have to understand HVAC system of TheShard. In HVAC system of TheShard, water is used to cooling system. Water enters TheShard at the basement level from street and fills the tanks. And there are tanks and pumps in 4 floors. Water rises up to the top of the building via those tanks and pumps. Tanks and pumps are located at 29 level, 51 level, 67 level, and 87 level at the spire. Why does not the pump system go up directly to the top? The answer is pressure. If pump sends water directly from basement to the top of the building, pipe at the bottom must withstand a pressure of 300 tons per square meter. Using these pumps, the heat is transported to radiator, which is located at the spire of the building. And radiator of the spire was not enough to take entire thermal energy. To add the cooling system of the building, flat roof space is needed for cooling towers. But TheShard is tapered foam, so it has very small roof space. So TheShard uses the small rectangular 18-floor extension to the east of TheShard, which called as backpack, contains most HVAC system. The roof of 18-floor extension was enough to install equipment which needs access to the outside air, such as cooling tower. In TheShard's HVAC, another focus point is CHP, Combined Heat Plant for energy efficiency. TheShard's each different space has different energy demand profiles, which experience peaks at different times of the day. Combined heat and power plant was suitable for this energy demand profile. When generated electricity, waste heat is also generated inevitably. In a common power plant, waste heat is emitted to the surrounding environment. Because power plant is usually too far away from city to utilize waste heat. But in TheShard, CHP generates electricity for the building and eliminates much of the need to heat, such as hot water and heating the building by using waste heat. CHP offers 1.13 MW of electricity and nearly 1.2 MW of heat. Efficiency is 85% total and 41% electrical. It is very efficient generator. Normal power plant efficiency is 33 to 48%. By this passive and active solution for the heat control of the building, TheShard uses 30% less energy compared to ordinary building. This helps to get TheShard excellent score of the BREEAM, which estimates the building's efficiency. This time, we talked about heat control system of TheShard. Next time, we'll present final presentation of TheShard. Thank you for listening. We're Team 3, TheShard.